Hey there, fellow coders. Welcome to my YouTube channel. I'm Praj, a software developer passionate about creating efficient and scalable systems. In this video series, we are diving into the world of Apache Airflow and how to run it on AWS using MWAA. That's Managed Workflows for Apache Airflow. And also, like in the process, we'll be trying a few new tools together. Whether you're a seasoned developer or just starting your journey, this series is designed to help you master a powerful tool in data engineering landscape. We will explore everything from the basics of Airflow to advanced AWS integrations, all while keeping things practical and fun. So grab your favorite editor, fire up your AWS console, and let's embark on this exciting journey together. While we are talking about Airflow, let's first get the definition of workflow out of the way. Most of the tools like Airflow, talking about Prefect, Mage, etc., will follow similar concepts. A workflow is a bunch of tasks grouped together, which can have dependencies. Let's take any ETL load as an example. Most of the times, the steps include extracting data from a source, transforming it in some sort of compute layer, and then loading it into the target. We always have to wait for the preceding step to complete before executing the next. Workflow management systems make programming such workflows easier. Workflows are generally scheduled to run at a particular cadence. Hence, many workflow managers have a built-in scheduler. Airflow does have one. The ones that don't generally depend on an external scheduler like cron for scheduling the workflows. Also, a workflow comprises of a group of tasks that are not cyclic. If there is a cycle in a group graph of tasks, then the workflow is never going to finish. I will soon show you an example of this when we look at a DAG later in this video. Till then, please bear with me for this point. Now let's break down into what we are going to learn in this video series. This chapter will be covering the basic concepts of Airflow. I'm not going too deep into what Airflow does, as there are numerous courses out there that explain this well. I'll be linking a few in the description down below. For the second chapter, we'll be setting up a local environment that will help us test out our workflows, or at least visualize them. We will also be writing our first directed acyclic graph in this chapter. Third chapter, we'll be setting our MWAA environment in AWS and deploy the tag which we wrote earlier to AWS. Then in the fourth one, we are going to be looking at monitoring, checking out the logs on how our DAG runs, as well as the result of the DAGs and where they would be stored. On the fifth chapter, we'll be adding more AWS services into the mix, like Redshift, and then we'll dive a bit into how could we configure AWS IAM policies so that Airflow can talk to these services. Sixth chapter is going to be a deep dive in monitoring and scaling using MWAA. Seventh chapter will dive into security best practices for MWAA. Here we'll be deploying Airflow in a private virtual environment and disable all public access to the Airflow web UI. Eighth chapter is about adding a new service that's outside of AWS to our DAG. I'm thinking of using Google Analytics right now, but might switch to something else. Please let me know in the comments below if you would like me to cover anything else. Ninth chapter is going to be on CI/CD. This is especially going to be for deploying DAGs. I won't be covering CI/CD for deploying infrastructure as code. 10th chapter, we'll be writing our own operator and deploy it on MWAA. Now let's talk about the tools we are going to use for this course. One obvious tool is AWS, as we will be running Airflow using a managed service provided by AWS. We are going to be writing Python, as that's the language of choice for Airflow. We are using Pulumi for managing infrastructure. I'll be using Pulumi's Python interface just to stick with one language. I've never used Pulumi myself, been a long-time Terraform user. So This course will take this journey together to learn Pulumi, and while working on it, I'll try to contrast it with Terraform. Maybe by the end of this series, I'll have an opinion on which tool is better for managing infrastructure. The last tool we will be using is GitHub Actions for deploying the DAG to S3. Let's take a look at important concepts in Airflow. The basic unit of work in Airflow is a task. It represents any action that we take as a part of a workflow. An operator is a template for a task, and it contains all the required code for interacting with any third-party system. A scheduler in Airflow is responsible for scheduling the tasks. It stores all the required metadata on the task runs in a metadata database. MWAA hides this detail from us while managing this database. A scheduler will instruct executor to run the task. Types of executors in Airflow are local executor, celery being a task processing library in Python, then Kubernetes executor, which runs on a Kubernetes cluster. Airflow has a pluggable executor system, and you can write your own executor based on the compute layer you use. Let me know if you are interested in learning how to use these different executors or writing your own in the comments below. I can create a video on that topic if there is interest. Airflow is a battle-tested workflow system with a lot of companies using it. I have been using Airflow for the past 6 years and really love the ease of writing workflows in it. Also, another huge advantage is that Airflow has an ocean of third-party integrations. If you want to extract data or interact with any system, probably Airflow already has an operator for it. Always make sure to search for an existing operator before writing out your own. We are at the end of this chapter. In the next one, we are going to set up our local Airflow environment for MWAA and also write our first tag. Don't forget to like this video if it has helped you in any way. Subscribe and hit the bell icon to get all the notifications for this course and the other videos that I'll be posting. Thank you for your time. Have a good day or a good night.